Welcome to this lecture on front-end theme design and login page implementation. In this session, we're going to walk through the thought process behind building a front-end theme, focusing on the most important parts of the product flow, and then dive into how to design and implement a clean, simple login page using Google Authentication. Let's get started. So the discussion starts by revisiting work done on the front-end theme from the previous session. The theme was built with quite a lot of detail initially, but the approach was then refined. Instead of trying to cover everything at once, the focus was narrowed down to the main, most important elements. The product view became the primary concern. This is actually a really healthy way to approach front-end development. Get the core right first and layer in the finer details later. Why does focusing on core elements first? When you try to build everything in full detail from the very beginning, it becomes overwhelming and easy to lose direction. By contrast, when you focus on the main elements, in this case the product view, you make faster, cleaner progress. You can always come back and add the smaller details. This is a principle that applies not just to front-end design, but to software development in general. The discussion then moves to what's called the normal flow, the standard path a user takes through the application. This flow starts with the user visiting the app, logging in, and then reaching the product view, where the core features live. Now, it's acknowledged that some things, like bike listings and a few other pages, will be missing at first, but that's okay. These are described as small pages with minor details, and they can be handled later. The important thing is to get the main flow working correctly. There's an important mindset being communicated here. Missing links, incomplete navigation, and small detail pages, these are not blockers. They should be treated as individual tasks that you pick up and complete over time. The advice is clear. Don't add extra complexity right now if it feels like too much. Start with what was originally planned, keep it simple, and then build on top of it week by week. This iterative approach keeps the project moving forward without getting stuck. The iterative development strategy being described here is straightforward. In the first phase, you build the core flow, the login and product view. In subsequent weeks, you come back and fill in the missing pages and details. And if needed, you can even recreate the project from scratch later with a better structure. This isn't a failure, it's actually a sign of growth. As you understand the project better, rebuilding with that knowledge leads to a much cleaner result. Now, let's talk about where the project actually begins. The product view is identified as the starting point. It's the first major screen that users interact with after they log in. This is where the core value of the application is delivered. So naturally, this is the screen that deserves the most attention and the most polish in the early stages of development. Before a user can reach the product view, they need to log in. So the login flow is the very first thing that needs to be built. The flow is simple. The user opens the app, lands on the login page, clicks Login with Google, gets authenticated through Google's system, and is then redirected to the product view. This is a clean, minimal flow, and that's intentional. The login page design follows a philosophy of radical simplicity. There is only one option on this page: Login with Google. No email and password fields, no other third-party login providers, just a single clear call to action. This is a deliberate design choice. The fewer options you give users on a login page, the less confusion there is, and the faster they get to the actual product. Why choose only Google Login and skip the traditional email and password approach? The reasoning is practical. With email and password login, you need to handle password storage, password reset flows, email verification, and a lot of additional back-end complexity. With Google Login, the user clicks one button, Google handles the authentication, and you get back a verified user. It's simpler, more secure, and faster to implement. For this project, that's exactly what's needed. An interesting detail in the workflow here is the use of DeepSeek, an AI tool, to generate the initial theme design. Rather than designing the login page and overall UI from scratch, the theme was provided to DeepSeek, which produced a design that serves as the starting point. This is a great example of how AI tools can accelerate front-end development, especially in the early stages when you just need something solid to build on top of. Another practical point being made here is about reusing prior work. Rather than starting from scratch every time, the approach is to go back into the history of what was previously created, login feature designs, code snippets, theme configurations, and reuse them as a foundation. This is efficient development in action. You build something, you refine it, and you carry it forward. There's no need to reinvent the wheel every session. So let's talk about what Laravel Socialite actually is, because this is the core package that makes Google Login, and really any social media login, possible in a Laravel application. Socialite is an official Laravel package that you install through Composer. What it does is act as a bridge between your Laravel app and external social media platforms like Google, Facebook, X, and LinkedIn. Instead of you having to manually implement the complex OAuth protocol, which involves redirecting users, exchanging tokens, and verifying identities, Socialite handles all of that for you. The instructor installed it using a composer require command, which we'll look at more closely in a moment. The installation is straightforward. You run the composer require command, specifically composer require Laravel-Socialite, and composer pulls the package into your project. The instructor noted they were on version 1 at the time, but you should always check the Laravel documentation at laravel.com and search for Laravel Socialite to find the correct version compatible with your Laravel installation. Once you run this command, you just wait for it to finish installing, and then the package is ready to be configured and used. The instructor ran this command in the background while continuing to work on other parts of the project. Now, let's understand the actual flow of how social login works, because this is fundamental, and the instructor makes a really important point here. This flow is the same for every single social media provider, whether it's Google, Facebook, X, or LinkedIn. The steps are identical. First, the user clicks the Login with Google button on your site. Your app then redirects them to Google's own login page. The user authenticates there, enters their Google credentials. Google then redirects them back to your application, and crucially, it sends along a token. Your app uses that token to retrieve the user's information from Google. And finally, the user is logged into your application. The only thing that changes between providers is the source of that token and some provider-specific configuration. Socialite abstracts all of this complexity away. The instructor makes an interesting practical note here about why they chose Google specifically for this demonstration. Facebook's OAuth security policies are stricter. When you're working on localhost, Facebook often won't issue tokens directly to a local development environment. You'd need to deploy your application to a real server before Facebook login would work properly. Google, on the other hand, is more permissive in development and allows you to configure localhost as a valid redirect URI. So for the purpose of learning and demonstrating the concept locally, Google is the practical choice. The instructor mentions that other providers might have similar restrictions, so keep that in mind when you're building and testing social login features. Now let's look at how the instructor structured the code. When building the Login with Google feature, you need a dedicated page for the login view. That's the login.blade.php file inside the front auth folder. To serve that page, you need a controller. The instructor chose to create a brand new controller specifically for authentication, called Auth Controller, rather than stuffing this logic into an existing page controller. This is good practice because it keeps your authentication logic clean and separate. The artisan command used is php artisan make controller front/auth controller, which creates the controller inside the front subfolder, keeping things organized by section of the application. Inside the auth controller, the instructor defines a public function called login page. This is a simple method. It just returns a view. The view it returns is front.auth.login, which in Laravel's dot notation maps to the file at resources/views/front/auth/login.blade.php. So when a user visits the login route, this method fires, and it serves up the login page blade template. This is the page that will contain the Login with Google button. The routes file is where things start to come together. 3 routes are needed for the full Google login flow. The first is the basic login route. It maps to the login page method in Auth Controller and is named simply login. The second route is the Google redirect route, named google.redirect. This is the route that gets triggered when the user clicks the Login with Google button. It will redirect the user over to Google's authentication page. The third route is the Google callback route. After the user authenticates on Google, Google sends them back to your application at this URL. The instructor emphasizes that the route name google.redirect must match exactly what is referenced in the Blade template. If you change the name here, you must update it everywhere it's used. It's worth pausing to understand why exactly 3 routes are needed. Think of it as a 3-step handshake. The first route just shows the login page, nothing special there. The second route, the redirect route, is what actually kicks off the OAuth process. When the user clicks Login with Google, they hit this route, and Socialite takes over and redirects them to Google servers. The third route, the callback, is the URL you register with Google in advance, telling Google, after the user logs in, send them back here. Google then redirects the user to this callback URL along with a token. Your app picks up that token and uses it to fetch the user's profile. Each route is a distinct step, and all 3 must be in place for the flow to work end-to-end. For the login page itself, the instructor focused on design rather than building it from scratch. The page uses the existing front-end layout that's already set up in the project, so it inherits the header, footer, and styling automatically. The key element on this page is the Login with Google button. The instructor also cleaned up the page by removing some unnecessary scripts that were included in the original design template, specifically a Google script tag that wasn't needed for this implementation. The button is linked to the google.redirect named route, so when a user clicks it, they get sent through the OAuth flow we just described. The instructor also noted that the sign-in link in the header component was already pointing to the login route, so clicking Sign in the navigation takes users to this page. One small but important detail. In the header component of the front end, the sign-in link was already wired up to use the named route login. This is a best practice in Laravel. Instead of hard-coding a URL like /login, you use the route helper function with the route's name. That way, if you ever change the URL of your login page, you only update it in one place, the routes file, and every link that references the name automatically updates. So clicking Sign in the navigation bar takes the user to the login page, where they can then click Login with Google to begin the OAuth process. One of the most powerful aspects of Laravel Socialite is its consistency across providers. It supports Google, Facebook, X, formerly Twitter, LinkedIn, GitHub, GitLab, Bitbucket, and more. And here's the elegant part. The code you write is nearly identical regardless of which provider you're using. You call Socialite, specify the driver, which is just the provider name as a string, and then call redirect or user. So if you build Google Login today and want to add GitHub Login tomorrow, you're essentially copying the same pattern and just swapping out the driver name. The instructor focuses on Google for this demonstration, but the knowledge transfers directly to any other provider. Let's take stock of where things stand. Socialite has been installed. A dedicated auth controller has been created inside the front folder to handle authentication logic. The login page method is in place and returns the login blade view. 3 routes are defined, one for the login page itself, one to trigger the Google redirect, and one to handle the callback from Google. The login page design is done with the Login with Google button wired to the redirect route, and the header sign-in link points to the login page. The foundation is fully in place. Coming up next, we'll look at how to configure the actual Google OAuth credentials and implement the redirect and callback methods in the controller, which is where Socialite really shows its power. Continuing from where we left off, when we set up Google OAuth, one of the most critical pieces is the redirect URL. Think about what's happening here. Your Laravel app sends the user over to Google for authentication, and Google needs to know where to send them back. That destination is your redirect URL. And here's the key thing. The URL you define in your Laravel app and the URL you register in Google Cloud Console must be exactly the same. If they don't match, Google will reject the request entirely. So let's walk through setting up Google Cloud Console from scratch. First, just search for a Google Cloud Console in your browser and navigate to it. Sign in with your Gmail account. Once you're in, you'll see a project selector at the top. Click on it. If you don't have a project yet, click New Project. Give it a meaningful name. In this case, the name used is Southern Hub. Leave the organization as No Organization for personal or testing projects, and hit Create. Once it's created, make sure you select that project so all your subsequent steps happen inside it. Once you're inside your project, navigate to APIs and Services, and then click on Credentials. Now, the first time you do this, you might see a warning that the OAuth consent screen hasn't been configured yet. Don't ignore that warning. You need to set up the consent screen before you can create credentials. The good news is this is a one-time setup per project. After the first time, you won't need to do it again. The OAuth consent screen is basically what users see when they're asked to grant your app permission to access their Google data. You need to fill in a few fields: the app name, which should match your project name, and your email address for both the support contact and the developer contact. For the user type, you have 2 options: internal, which restricts access to users within your organization, and external, which allows any Google account to authenticate. For development and testing purposes, choose external. Then click Continue and Save. Now you're ready to create the actual credentials. Go to Credentials, click Create Credentials, and select OAuth 2.0 Client ID. Set the application type to Web Application and give it a name, something like your app's name. The most important part here is the authorized redirect URI. This must be the exact same callback URL that you've defined in your Laravel application. Once you click Create, Google will give you 2 things, a client ID and a client secret. Copy both of these and paste them into your Laravel.env file under Google Client ID and Google Client Secret. These are the credentials your app will use to communicate with Google. A couple of important questions come up here. First, does it matter if you use your personal developer Gmail to create the credentials? The answer is no. It doesn't negatively affect your end users. You can use your own Gmail account, and it works perfectly fine even in production. Second, what happens if that Gmail account gets deactivated? Well, the OAuth token that was created under that account will expire and become invalid. Your app's Google login would stop working. So the practical advice here is to use a stable, long-term Gmail account when setting up your Google Cloud project and credentials, not a throwaway account. Let's now look at the complete authentication flow from start to finish. When a user clicks Continue with Google, your Laravel app redirects them to Google, passing along your client ID and the redirect URL. Google shows the user a consent screen. They approve it. Google then redirects back to your callback URL with an authorization code. Laravel uses that code to fetch the user's data, things like their name, email, and profile photo. Then Laravel checks your database. Does this user already exist? If yes, just log them in. If no, create a new user record and then log them in. Finally, redirect the user to the homepage. And here's the important thing. This exact same flow works for every social provider. Facebook, GitHub, you name it. The code structure is identical. After the Google login flow completes, if you check your database, specifically the users table, you'll find that a new record has been created automatically. Even though the user never filled out a registration form, their name, email, and profile photo from Google have been saved to your database. On top of that, Laravel has created a session for this user, meaning they are now fully authenticated. The front end might not look any different yet, but the back end has done all the heavy lifting. The user is logged in, the session exists, and the data is in the database. Now that authentication is working, we need to control which pages users can and cannot access based on whether they're logged in. This is where middleware comes in. The idea is to create two types of middleware. The first is the auth middleware. Let's call it auth user, which only allows logged-in users through. If someone tries to access a protected route without being logged in, they get redirected to the login page. The second is the guest middleware, guest user, which works the opposite way. It only allows guests, meaning users who are not logged in. If a logged-in user tries to visit the login page, they get redirected to the home page instead. Think of middleware as a gate that sits in front of your routes and decides who gets through. To create the middleware, run two artisan commands, make middleware auth user and make middleware guest user. Inside the auth user middleware, the logic is straightforward. Check if the user is authenticated using authguard web. If they are, call next request to let them through. If they're not, redirect them to the login page. The guest user middleware is the mirror image. If the user is authenticated, redirect them to the homepage because they don't need to see the login screen again. If they're not authenticated, let them through to the login or register page. Notice that both use the WebGuard specifically. This ensures we're checking web-based session authentication. Creating the middleware class is only half the job. You also need to register it in the application's HTTP kernel, which lives at app/http/kernel.php. Inside the route middleware array, you add an alias for each middleware. Here, the auth user class is registered under the alias auth, and guest user is registered under guest. These alias names are what you'll use when applying middleware to your routes. Without this registration step, Laravel won't know what you mean when you reference these names in your route files. Now let's apply the middleware to actual routes. In your web.php routes file, you group routes together using the middleware method. All the guest-only routes, like login, register, and forgot password, go inside a group with the guest middleware. This means if a logged-in user tries to visit /login, they'll be immediately redirected to the homepage. On the other side, routes that require authentication, like the cart page or the logout action, go inside a group with the auth middleware. Anyone who isn't logged in and tries to access those routes gets sent to the login page. Grouping routes this way keeps your route file clean and makes the access control logic very easy to read. When you test this, the behavior is exactly what you'd expect. A logged-in user who tries to navigate to /login gets immediately redirected to the homepage because the guest middleware catches them and says, "You're already logged in, go home." A guest who tries to access the cart page gets redirected to the login page, and a logged-in user accessing the cart goes right through. The beautiful thing about middleware is that you write this logic once, register it once, and then apply it to as many routes as you want. You don't need to put if-else checks inside every single controller method. For logout, a delete route is defined pointing to a method in the auth controller. Here it's named delete. Inside that method, the logic is simple. Call auth logout to destroy the session, then redirect the user back to the login page. One important detail, this route uses the delete HTTP method, not get or post. So in your Blade template, your logout button needs to be inside a form that either uses method delete directly or includes the Blade method spoofing directive with delete. If you use the wrong HTTP method, the route won't match and you'll get an error. Middleware handles back-end route protection, but you also want the front end to reflect the user's authentication state. In your Blade templates, you can use an if check with off-guard web check to conditionally show different UI elements. If the user is not logged in, show a sign-in button. If they are logged in, show a logout button instead. This way, a logged-in user won't see a sign-in button, and a guest won't see a logout button. The back-end middleware and the front-end conditional rendering work together to create a seamless and secure user experience. Let's step back and appreciate why middleware is such a powerful concept. First, it gives you single responsibility. You write the access control logic in one place and apply it wherever you need. Second, it's completely reusable. The same auth user middleware can protect your cart, your orders, your profile, your checkout, any route that requires a logged-in user. Third, it's highly customizable. Right now, the logic checks for login status, but you could extend it to check for user roles, subscription plans, IP addresses, or anything else your application needs. The key insight is that middleware sits between the request and the route, giving you a clean interception point. Once you grasp that concept, building secure, well-structured applications becomes much more manageable. With authentication and middleware now in place, the next piece to tackle is the product listing on the cards page. The requirement here is that products shouldn't just be dumped into one flat list. Instead, they need to be organized and displayed shop by shop. Each shop gets its own section, and its products are listed under it. This means on the database side, we'll need a query that groups products by their associated shop. Coming up, we'll look at how to build that grouped product display and wire it up to the front-end card layout. So here's the core idea we need to understand. We want to compare login data, check whether a user exists, whether credentials match. And for that, we need data from Google's database. But here's the thing, our backend cannot directly access Google's database. Nobody can just walk in and query it. Instead, Google has built an API, a controlled gateway, and we have to hit that API. Our application sends a request to Google's API. The API does all the checking against its own database, and then it redirects the user back to our website. That's the complete flow. Our app talks to Google's API talks to Google's database, and the result comes back to us. Now, just because Google has an API doesn't mean anyone can use it freely. Google needs to know which application is asking for user data. Think about it. When a user logs in through our app, their personal data is flowing into our system. Google has to be sure that only authorized applications can do this. So just like we generated Sanctum tokens for our own API earlier, we need to obtain a token, actually a set of credentials from Google. Specifically, we need three things: a client ID, which identifies our application, a client secret, which proves our app is legitimate, and a callback URL, which is the link Google uses to send the user back to our website after authentication. These three pieces are the foundation of the whole Google login flow. Let's map out the complete flow visually. There are two routes our application needs. The first route handles the redirect. When the user clicks Login with Google, this route takes them from our UI to Google's login page. From that point on, Google takes over. The user sees Google's interface, picks their account, and authenticates. Then comes the second route, the callback. Once Google is done, it sends the user back to our application using the callback URL we provided. This is where Google delivers the user's data to us. So to summarize, Route 1 sends the user from our app to Google. Route 2 receives the user back from Google into our app. 2 routes, 2 directions, 1 complete login cycle. Now let's look at the actual setup. The first step is installing Laravel Socialite using Composer. Once installed, we need to configure it. We go to the config/services.php file and add an entry for Google. The structure here is important to understand. The right-hand side, client ID, client secret, and redirect, these key names are fixed. Socialite expects exactly these names, so we cannot change them. What we can change is what's on the left side of the NV calls, the names of our environment variables. In this case, we're naming them Google Client ID, Google Client Secret, and Google Callback URL. Whatever names we choose here must also exist in our .env file with the actual values. The name Google given to this service block is also our choice. It's what we'll reference when calling Socialite later.
This is a really important security practice. Our client ID, client secret, and callback URL are confidential credentials. We should never hardcode them directly in our config files or push them to GitHub, where anyone can see them. Instead, we store them in the .env file, using environment variables. The .env file holds the actual values and must never be pushed to Git. But here's the smart practice. We also maintain a .env.example file, which has the same variable names but with empty values. This file is pushed to Git. Why? Because if you clone this project later or a teammate pulls it, they can look at .env.example and immediately know which variables they need to set up. They just generate their own credentials and fill them in. The keys tell you what's needed. The values are yours to obtain freshly. Now we define the two routes. The first route, auth/google/redirect, is what gets triggered when the user clicks Login with Google on our page. It calls the Google redirect function in our controller. The second route, auth/google/callback, is the URL we give to Google. When Google finishes authenticating the user, it sends them back to this URL, which triggers the Google callback function. One critical thing to note, the callback route URL here must exactly match what you put in Google callback URL in your .en file. If they don't match, Google will refuse to redirect back to your app. These two routes are the entry and exit points of the entire Google authentication flow. The redirect function is beautifully simple. All it does is call Socialite's driver method with the string Google, and then call redirect on it. When this runs, Socialite looks up the Google entry we defined in config.services.php, reads the client ID, secret, and callback URL from our environment variables, constructs the proper Google OAuth authorization URL, and redirects the user's browser to Google's login page. From that point, Google handles everything, showing its own UI, letting the user pick their account, verifying their print health. Our job in this function is just to point the user toward Google. That's it. One line of code does all of that. Now here's the callback function. This is where the real logic lives. When Google sends the user back to our callback URL, we call Socialite's user method to retrieve the authenticated user's data. This data lands in the $Google user variable. It contains publicly available profile information like the user's name and email address. Now we need to decide, is this person already in our database or are they brand new? We check by searching our user table for a record with the same email address. If we find one, the user already exists, we simply log them in using auth.login and redirect them to the homepage. If we don't find one, we create a new user record. We set their name and email from the Google data, and for the password, we assigned a random number. Because this user will always log in via Google, they'll never need to type a password. We save the new user, log them in, and redirect to home. You might be wondering, why are we storing a random password at all? The answer is that our users table has a password column, and it's required. But for users who sign in with Google, they will never type a password into our app. Google is their authenticator. So we just need to put something in that column to satisfy the database constraint. A random number works fine for this purpose. The user will never know what it is, and they'll never need to use it. Every time they want to log in, they'll click Logging with Google and go through the OAuth flow. In production, you typically use something like str.random and hash it with bcrypt for better security. But the concept is the same. It's a placeholder that keeps the database happy while Google handles the actual authentication. Let's bring the entire flow together in one picture. The user clicks Login with Google, our first route fires, the redirect function runs, and Socialite uses our client ID and secret to build the Google OAuth URL. The user lands on Google's login page, picks their account, and Google does its own verification. Once done, Google sends the user back to our callback URL, our second route. The callback function receives the user's data through Socialite. We then check our own database. Does a user with this email already exist? If yes, we log them in directly and send them home. If no, we create a brand new user record with their name, email, and a random password, log them in, and send them home. Both paths end at the same place. The user is authenticated and on the homepage. This is the complete end-to-end Google OAuth login flow using Laravel Socialite. Continuing from where we left off, the next step is wiring up the cart functionality with its own dedicated routes in controller. Two routes are needed here, a get route for the carts page, which maps to the index function, and a post route for adding items to the cart, which maps to a store function. The route name given to the store action is cart.store. This naming is important. We'll see why in a moment. The controller itself is generated inside the front-end directory using Artisan's make_controller command, keeping the front-end logic neatly separated. When the Artisan command is run to generate the controller, it scaffolds out quite a few functions automatically, more than what was explicitly asked for. This is actually helpful.
The index function is copied over from an existing pattern and pasted in. Rather than keeping the default snake case naming that Artisan might suggest, camel case is preferred here. So instead of clear cart, it becomes clear cart. Instead of remove item, it becomes delete. And instead of update quantity, it's simply update. These are small stylistic choices, but consistency in naming conventions across a codebase matters a lot.
Once the controller is ready, the routes are registered. There's a critical point to understand here. The route names, like card.store, must not be changed. The AI-generated code references these named routes internally in multiple places. If you rename them, things will break in ways that are hard to trace. However, the URL path itself, the string like /card/add, can be changed freely. Only the name attribute is locked in. The controller is also imported at the top of the route file, so Laravel can resolve it correctly. The add to cart function is copied from the AI output and pasted into the controller. But here's where careful reading is required. The AI used its own naming conventions. For example, it referenced cart.add, but our route is named cart.store. It used remove item, but we named our function delete. It used update quantity, but we simplified ours to just update. And it used snake case clear cart, while we wrote camel case clear cart. Each of these mismatches needs to be manually reconciled. This is a very common situation when working with AI-generated code. The logic is usually correct, but the names need to align with your actual project structure. Something interesting about the AI-generated code here, it didn't just write a simple form submission. It wrote JavaScript that performs live, real-time cart updates without refreshing the page. This is done through AJAX, asynchronous JavaScript and XML, which sends requests to the server in the background and updates only the relevant part of the page. On a local development server, this might feel a bit slow, but on a production server, it's fast. Now, if this live update behavior isn't needed, you can absolutely replace it with a normal form post pattern. The AI just happened to go the more advanced route. Either approach is valid. One of the errors that came up was related to JSON decode. Here's what happened. The AI assumed that the images field in the database was stored as a plain string, which is common in many setups. So it wrote JSON decode to convert that string into a PHP array. But in this project, the model already has a cast defined for images as an array type. That means Laravel automatically decodes it. By the time your code runs, images is already an array. Calling JSON decode on an array throws an error, must be of type string, array given. The fix is simple. Remove just the JSON decode call, but keep the variable itself, because it's likely used further down in the function. When errors appear, knowing where to look is half the battle. Front-end errors, things like a missing AJAX library link, JavaScript issues, or a route not being found from a JavaScript call, these show up in the browser's developer console. Open the browser, press F12, and check the console tab. Back-end errors, PHP exceptions, database problems, undefined method calls, these appear in Laravel's log file, found at storage/logs/laravel.log. Check the last few lines of that file. One important nuance. If you see a call to undefined method error in the log, it might be an old error from before your fixes. Always check whether the error is actually current or was already resolved. One specific issue that came up was that the AJAX call wasn't working at all, and the suspicion was that the AJAX library itself wasn't linked in the layout file. When JavaScript tries to make an AJAX call but the library isn't loaded, it fails silently or throws a vague error. The fix is to check the main layout blade file and ensure the AJAX or jQuery script tag is present and loads before any cart-related JavaScript. There was also a route does not exist error that turned out to be caused by the user not being logged in. The auth check was redirecting to the login page instead of processing the cart action. The solution there was simply to log in first and then test the functionality again. Another route that needed to exist, even if the full functionality wasn't built yet, was the checkout route. The checkout route takes a DuCon ID as a parameter, and it needs a name so that other parts of the application can reference it. The name given is checkout.ducon. A dedicated controller for checkout will be built out later, but for now, just having the named route registered is enough to prevent route not found errors from crashing the page during development. This is a good practice. Register your named routes early, even as placeholders, so the rest of your views and links don't break while you're still building. To bring this section together, working with AI-generated code in a real project like this surfaces a few consistent lessons. First, the AI scaffolding is genuinely useful and saves a lot of time, but you must reconcile the names it uses with your actual route names, function names, and variable names. Second, the AI might reach for advanced patterns like AJAX live updates. Understand what it's doing and replace it with a simpler approach if that better fits your needs. Third, the AI can misread your model's configuration, like assuming images is a string when your model already casts it as an array. And fourth, always debug systematically. Front-end problems go to the browser console, back-end problems go to the Laravel log. The real skill here isn't just copying AI output, it's being able to read it, understand it, and fix it when it doesn't quite fit.
So here we have a classic runtime error. The error message clearly says call to undefined method on something called inRandomObject. What this means is that the code is trying to call a function called inRandomObject on a model, specifically the product model, but that function simply does not exist there. The error is being very explicit about where the problem is. The product model does not have this function defined, and yet the code is trying to look for it and call it.
So what was the root cause here? The developer was probably trying to fetch a product randomly. That seems to be the intent. But the method they called, inRandomObject, was never actually defined inside the product model. This is a very common mistake. You write a call to a function that either you forgot to define or that you intended to define but never did. The fix is straightforward. Remove that invalid method call and replace it with a valid one. In this case, simply using something like a get call to retrieve a record directly would work just fine.
Here is exactly what was done to fix the error. The developer copied the problematic method name from the error message, used Ctrl+F to find it in the codebase, and then Ctrl+H, or find and replace, to locate and remove it. The invalid inRandomObject call was stripped out, and the code was replaced with a straightforward get call. Once that change was saved, the live reload kicked in and the fix was reflected immediately in the browser. This is a great example of how reading your error messages carefully leads you directly to the solution.
After fixing the error, attention turned to some UI cleanup. Specifically, a Checkout All button, along with a grand total and order summary section, was being shown on the cart page. But this doesn't make logical sense in this application. Here's why. Each store is a separate entity, and orders from different stores happen at different times. You cannot place a single combined order across multiple stores at once. So the Checkout All button, the grand total, and the combined order summary were all removed from the page. Each store gets its own individual checkout flow.
The order summary section, which shows the total cost and items, is intentionally being deferred. It will not appear on the cart page. Instead, it will be shown on the dedicated checkout page when the user actually proceeds to check out. This is a deliberate design decision to keep the cart page clean and to put the full order summary in the right context. This part of the UI is being skipped for now and will be revisited when the checkout flow is built out. Some header navigation improvements were also made. The magnifying glass search icon in the header was wrapped inside an anchor tag with a named route, so that clicking it actually navigates the user to the correct page. This is a small but important detail. Icons that look clickable should actually be clickable and should route the user somewhere meaningful. Using named routes in the anchor tag keeps the code clean and maintainable.
At this point in the session, a student shared their screen to get help with their own error. The error was related to a variable called dokkan, which is the Nepali word for shop or store, not being found in the request. To debug this, the instructor guided the student to navigate to the relevant controller file, specifically the page controller inside the front-end folder, and inspect what variables were actually being passed through the request object. After formatting the code in the controller to make it readable, it became clear that the dokkan variable was being correctly populated from the request. It was pulling in the name, email, and contact fields from the form submission. All the expected values were present. The dokkan variable was then being passed into a notification class called dokkan request notification, so the variable itself was fine. The issue had to be somewhere else in the chain. To trace the error further, the instructor directed the student to follow the flow of the data from the form submission through the page controller and then into the dokkan request notification mail class. The error was somewhere inside that notification class. The student needed to navigate into the email folder and open the dokkan request notification file to inspect what was happening there. And here was the actual bug. Inside the mail class, the student had accidentally defined two constructor functions. The first one had a spelling mistake in the name. It was something like CONSARUCTION with an extra underscore or wrong characters, so PHP did not recognize it as a valid constructor at all. The second one was the correct PHP constructor, _construct. In PHP, you can only have one constructor, and it must be spelled exactly as construct with double underscores on both sides. The fix was simple. Delete the incorrectly named duplicate constructor and keep only the valid one.
One subtle but critical detail came up during this fix: the number of underscores. In PHP, magic methods like the constructor use exactly 2 underscores before the method name. The student had accidentally typed 3 underscores at one point, which of course makes PHP treat it as a completely different, unrecognized function name. This is the kind of typo that is very easy to miss visually, but causes the entire class to malfunction. The rule is simple: always use exactly 2 underscores, no more, no less, when writing PHP magic methods like underscore underscore construct. Once the duplicate constructor was identified and deleted, specifically the one on line 26 that had the spelling mistake, the file was saved and the email notification service was tested again. With only one valid construct method remaining, the class could initialize properly, and the notification was sent correctly. This is a great reminder that even a single character typo or an accidental duplicate function definition can bring down an entire feature.
Let's wrap up with the key takeaways from everything covered in this session. First, always read your error messages carefully. They are not just noise. They tell you exactly what went wrong and where. Second, use find and replace tools to quickly locate problematic code in your codebase. Third, a call to undefined method error simply means you are calling a function that does not exist. Remove it or replace it with a valid one. Fourth, PHP magic methods like the constructor require exactly 2 underscores. Not 1, not 3, exactly 2. Fifth, never define duplicate constructors in a class. PHP will get confused and your class will not initialize correctly. And sixth, when tracing a bug, follow the data flow from the form submission through the controller and into the model or notification class. In the next session, the focus will shift to building out the full checkout flow.